So let us start with our algebraic fractions. All right, so we will be adding and subtracting algebraic fractions. All right, I want that open and I want that open. Okay, cool. Now, fractions generally, it's quite a notorious section for people. And then when it comes to algebraic fractions, people start flipping out even more. So let us start with something very nice and simple. I give you a quarter plus 2 quarters. And I say to you, add those together. What does it give you? All right, and most people have given me the answers of 3 quarters. And that is totally correct because we have passed primary school, which is fantastic. So we know that we have added the tops of our fractions, being a numerator, while keeping the bottom of the fraction being our denominator to be exactly the same, because the denominator refers to the size of the parts and the numerator refers to how many of those parts we have. So therefore, when counting them together, there's no point in changing the denominator. Why? Because if you change the denominator, you're changing the size, not the amount. All right. So this is a situation that you've come across before. If I, for example, ask you for a half plus a third, I say to you, what does that equal? All right, so we've got one answer, 5/6. So you can enter this on the calculator or you can do it by hand, but the idea of doing it by hand is the one that I'm looking for at the moment. All right, so this comes out at 5/6. And this is a bit of an interesting scenario because not only does 1 plus 1 not give you 5, we're now changing the bottom, which is kind of exactly the opposite of what I just said, where I said here you don't change it. So why over here am I changing it? It's because I need to have the same denominators for me to either add or subtract fractions, because I can't take off an amount that I don't know how big it is relative to what I actually have. So a half, or breaking a whole into 2 parts, has a specific size. Now I break it into 3 parts and I want to take one of those 3 parts out. Well, how much is it? I'm going to have to try and judge where the third marking is. That's not good enough. That's not exact enough. Mathematics is an exact science. So we think we know about equivalent fractions. And equivalent fractions state that I can change this fraction into, for example, a different denominator, changing my numerator with it to stay with the same quantity, but in a more useful form. So I could say that a half is the same as 2/4, which it is. Quarters here is not going to help me. I could say that it's the same as 3/6. Well, that's going to help me a lot more because I'm able to transform a third into sixths as well. And there it would be 2/6. Now, how did I get this? Well, if I times the denominator by 3, I've got to times my numerator by 3 to keep my equivalence. And I chose 3 because this denominator was a 3. Similarly, I'm going to times this one by 2, and then of course the top by 2 to keep equivalence. And I chose 2 because this denominator was 2. Now that they are the same, I have the same size parts, and I can therefore add or subtract what I need to, and 3 plus 2 gives me my 5 out of 6, which is my correct answer, which is fantastic news. Now, what does that actually mean? So this sort of method is very important when it comes to algebra, because algebra is now going to come into your numerators or your denominators. And we're going to have to know how to do this method of finding a common denominator. So let's have a look at something like this. I gave you a half plus a third, and that equaled 5/6. If I now give you p/2 plus, let's keep this simple, p/3, and I say to you, add them together, then what are we going to do? Well, a lot of people start freaking out about this. You're like, you've got a variable in the numerator. What do you do? It makes no sense. Well, it's still fractions. It's still numbers. So the rules still apply. The only difference now is you may not see a number in the numerator. But remember, if there is just a p, we know that there's a coefficient there. And remember what a coefficient is? The coefficient is the number in the front. So if we don't see a number, the number is 1. So it's 1p/2 plus 1p/3. Fantastic news. So then what that means is we are actually able to do exactly the same method to add these together because my variables are not in my denominator. So one possible answer that has been given is p/6. So we're almost there. We have the idea of 6 in that you times by 3 and you times by 2. But you are forgetting about the equivalence for equivalent fractions. Because if I times the bottom by 3, I must times the top by 3. If I times the bottom by 2, I must times the top by 2. So that's not quite there. But p times 3 is 3p plus 2 times p is 2p over 6. And 3p plus 2p, adding like terms means you add the coefficients, 5p/6. And that should look remarkably similar to this one. And hopefully it does, because hopefully you remember that when we went through factorization a couple of lessons ago, we found that we could take out a common factor. Now, how would I take out a common factor here? And why am I throwing factorization into something that doesn't look like it needs it? Well, because it's another option for you to solve this. So that is a perfectly correct method, and there's no problem. However, what you can do is you can realize that P over 2, or 1P over 2, is actually a half of P. So this P out on the right just shows this fraction a little bit more easily for you to see. So we have a half P plus we have a third P. And we can take out a common factor of P here because these two things are being multiplied. And if I take out a P, what must I do? Well, I eliminate it from my one fraction and my other fraction, and then I write down what is remaining. Well, it's a half plus a third. And this in the brackets is a far easier calculation to do because this is just numbers now. And we already solved this. So this is either 5/6 of P, or you can now put the P back to the top and please always to the numerator, and then it'll look exactly like that. So there are uses of factorization more than just letting teachers see you squirm. All right. So what about if I give you a slightly more complicated example? What if I give you P over 2 plus Q over 3? And suddenly the answers have dried up. So I'll still give you another minute or two just to try work this out. So think about everything that I've taught you so far and see if you can solve that. All right, so we have a couple answers coming through, and the possibilities are, let me just change color for this. Actually, I'll change color for marking. So we have 3P over 6 plus 2Q over 6, and that's as far as it goes because the letters aren't the same. We've got a PQ over 6. We've got a P over 6. P over 6, I think, was the initial version. All right, so let's change color. So P over 6, not a good option because you're completely disregarding the fact that there's a Q. PQ over 6, better option because now there's a P and a Q. And we get it over 6 because you times by 3, you times by 2, so you get the 6. But then this P times Q, you're creating a bit of a problem because you're actually adding them, not subtracting, not multiplying. And also you're forgetting about the equivalence. Not a good option. This one, far better option because you're including the equivalence. So there's 3P over 6 plus 2Q over 6. This can be simplified, 3P plus 2Q all over 6. So in other words, one common denominator. And that cannot be simplified anymore because, as correctly stated, these two letters or variables are different. And you cannot add unlike terms or terms with different variables. So that is the end of it. So equivalent fractions are very important here. Could I use my factorization option for this one? No, I wouldn't be able to use it because I don't have the common factor. I don't have the same variable. All right. What about if my variable happens to be in my denominator? So what about if I give you 1 over 2m plus 1 over 3m? Then what do you come out with? So we have a couple of options, and they are 1 over 6m. We've got 5 over 6m. We've got another 5 over 6m. So 1 over 6m, unfortunately, again, you are forgetting the equivalence. So what is my denominator here? Well, my common denominator is no longer 6, it's now 6m. But we are still going to be multiplying by 2. And we are still going to be, not by 2, we're still going to be multiplying by 3, and here we're going to be multiplying by 2. But with my equivalence, I've got a times by 3 at the top and times by 2 at the top. So yes, you do end up with a 6m, but you can't just have a 1. Not a good option. But when you add these, you get 3 plus 2 does give me 5 over 6m. Good option. The other option you have is taking out a common factor. But what would the common factor be is not just m, is actually 1 over m, being that m is in my denominator. So it has to be 1 over. And then it is simply a half plus a third. And that comes out at 1 over m times 5 over 6, which is 5 over 6m. Exactly the same option. If you put the m in the top, you are wrong. Completely different answer. All right. What about if I give you something like, oh, that's a nice one. What about if I give you something like the following? Let's make this a little bit more difficult in its entirety. Let's say, let's do, all right, just check that's going to work out. I'm going to stretch your minds a little bit with this one. And I do want you to note this is slightly beyond what the curriculum requires from you, but I feel that it is necessary for you guys to just see where you are going, because if you can do this sort of thing, the ideas of everything in the textbook that you're going to have to do will be completely sorted. So you've got some answers. You've got 12xy over 8xy. You've got 3xy over 10yx. And those are the only options we have so far. we need to try and find an LCD, or a lowest common denominator here. And the fact that we got 8xy here is a very good sign. This is a huge problem because you cannot add my denominators together. So that automatically is wrong. All right, we have one more option. I'm just going to change color again back. So that is 3xy over 16xy. All right. Back. So the fact that we are looking for a number that both of these can go into is great. The fact that 2 goes into 8. So I'm going to have to multiply that by 4 to get to 8. However, my variables are different as well. So I need to have a y in my denominator here, and I need to have an x in my denominator here. So whatever I do at the bottom, I've got to do to the top. So I times by x on the top, and I times by 4y in the top there, which means that this numerator is incorrect, and that unfortunately is incorrect as well. But we will find that my denominator is 8xy. 3 times x is 3x squared, plus 4 times y is 4y squared, and that is as far as we can go. Now, as I said again, I'm going to re-emphasize, this is beyond the scope of your syllabus. You will not have to deal with a time where your denominators are different things. However, the same idea applies. But please make sure you need to work towards having the same denominator, or you cannot add or subtract fractions. That's it, blatant rule.